Hey guys, here's section 9.4, inscribed angles. And again, here's an activity that I would love for you to try on your own. Before I show you how to do it, I'd love for you to follow this 5 steps and see if you can figure out and make a conjecture there at the bottom. So give it a try. If you pause it right now and then try it on your own, and then you can turn it back on and I'll show you how to do it. Alright, so here is step 1. It says draw a central angle and label the central angle COD. So here would be, yours might be in a different spot, and they could be up here, down here on the side, wherever. You just want to have a central angle that's a COD angle. So you need a C and a D endpoints, and you need O in the center. And then we want to measure angle COD. So I'm going to take our protractor. You may not have had a protractor, so you may not have been able to measure it on your own. But let me get my measurement here. So let's see, my angle is the inside numbers. It's going to be 65 degrees. Okay, so for me, I'm looking at 65 degrees. Okay, then it says to locate point A, so that arc CAD is a major arc. So CAD is major, so A needs to be somewhere out here. So for me, what I did is I put it like that. And then they want you to draw in the angle CAD this time. Basically taking this O and stretching it back to here. And then they want you to measure angle CAD. So then I need to take my protractor, oops, put it right on here. And it should be 32 and a half, right between 32 and 33. So it's going to be about 32.5 degrees. Now you could put 32, you could put 33. There's a reason why I'm putting 32.5, which you'll see in a minute. And if yours was an even number up here, if yours was 66 or 64, you would have had an even number down here. So if I measured this, then if I compare the two answers, would be my next step. Compare the two answers. If you look at them, the inscribed angle, which is this angle A up here, is exactly half of the central angle, which was 65. If you take 65 and cut it in half, you get 32 and a half. In other words, the measure of angle CAD is 1/2 times the measure of angle COD. When you take an angle and stretch it back to an inscribed angle, you're cutting the angle in half is what you're doing. So if you want to make a conjecture, here it is. If the measure of a central angles equal their intercepted arc, the central angles equal their arcs, then the inscribed angles are going to be half of their arcs. That would be a conjecture. All right, moving on. You can pause it if you need to. Some vocabulary terms. Inscribed angle. We just saw what an inscribed angle was. It's an angle where the vertex is on the circle and it's going to be half of the arc. A central angle is where the vertex is in the center and it's going to equal the arc. So arc, if this is like 60 degrees, this is a 60-degree angle. That means this will be a 30-degree angle. Inscribed angles are always half of the arc. So the measure of an inscribed angle is half of the measure of its arc. That's always going to happen for inscribed angles. So if you see this one down here at the bottom, again, you can pause it anytime you need to. If you see this one down here at the bottom and it's a 65-degree angle and it's touching here, which was just what I had on the previous page, then the arc, it was a little different. The arc, though, is going to be twice as much as the angle. So if they're giving you the angle, you can take the angle and double it and you'll get the arc. If they give you the arc, you can cut it in half to get the angle. So right here, it's 65-degree angle, double it, you'll get your arc of 130 degrees. Now on this one, we want to find out what this arc is so we can cut it in half. If I've got 84 plus 60, so if I've got 84 and I'm adding 60, that's going to give me, oops, that's going to give me 144 degrees. So that is this arc down here. If I take 360 and I subtract 144, that's going to give me 212 degrees. That means this arc around here is going to be 212. That's this arc out here. Now, to get my angle, I need to know what half of 212 is. So my angle is 108. Well, let me see. I must have subtracted wrong here. Oh yeah, it's 216. Sorry, my bad. Let's change that to 216. So yeah, then it's going to be 108 degrees. There you go, 108 degrees for this angle right down here, 108. All right, moving on. If two inscribed angles of a circle intersect the same arc, then what can we say about the angles themselves? So if angle C is intersecting AB, angle D is also intersecting AB, then angle C and angle D must be congruent. So if the two angles are intersecting the exact same arc, the angles have to be the same. They're opening up to the same arc, so there's the same measure. Another theorem that we have down here is a right angle. If you have a right angle that's 90 degrees and you double that, that means the arc has to be 180. And what do we know about 180 degrees? Well, hopefully all of you in your heads are saying 180 degrees is a semicircle. So if I have a 90 degree angle here, I'm going to have a 180 degree arc, which is really going to make a half a circle here. So it's got to be the diameter is the hypotenuse, because it's opening up to 180 degrees, and a 180 degree line is a diameter. So the only way that you can actually get a right triangle into a circle is to make the hypotenuse your diameter. So if you've got a right triangle that's inscribed, that means the right angle is inscribed, it has to be the diameter as the hypotenuse. That's the only way you could get a right triangle to come inside, because the angle is half of the arc. The arc has to be 180, which is a diameter, and then the angle then would be 90 degrees. If a quadrilateral is inscribed into a circle, quadrilateral means four sides. If a quadrilateral is inscribed into a circle, then the opposite angles must be supplementary. Opposite angles are across from each other. That means A plus C has to be supplementary. B plus D has to be supplementary. So A plus C has to equal 180. Angles B and D are also supplementary. That means they would also add up to 180. So that is for every quadrilateral that you put inside of a circle. That has to happen. Moving on. You can pause it if you need to. All right, what is the measure of each inscribed angle in a five-pointed star? So if you've got a five-pointed star and you want to know what each angle is, then we know that all five angles are equal, because it's our star. So we've got five equal angles. We know the whole circumference and the whole of degrees is 360 degrees in a circle. So the entire degrees in a circle is 360. Take the 360 and divide it by 5. That means you'll get 5 arcs. 3, 4, 5 arcs. Now each arc is going to be 72 degrees. So each arc, A to E is 72, E to D is 72, C to D is 72. They're all 72 degrees. Since this angle C is half of this 72, inscribed angles are always half of their arcs. Just take the 72 and divide it by 2 and you get 36 degrees. So that means each angle of this star is going to be 36 degree angles for all five. Example 3, they want us to find the measure of angle BAD. B to A to D, they want to know what this angle is right here. Well, we know that arc BC is 80 degrees. So this arc down here, 80 degrees. And arc CD is 100 degrees. 100 degrees. In your head, you should be able to add 80 plus 100. That means this whole arc is 180 degrees. So if I was to draw a line straight across, that would be my diameter from B to D would be my diameter. If I was to draw a line straight from point B to point D, it would be a diameter. I was supposed to go through the center of the circle there. So my picture is a touch off, but from B to D would be a diameter because this is 180 degrees. So guess what angle A has to be? It's got to be half of this 180 degrees. So BAD, angle BAD intersects arc BCD, which is 180 degrees, and angle BAD is half of arc BCD. So you get 180 divided by 2, you get 90. And I hope you pause the videos and really look and in your mind see all of these pieces and exactly how I got each number. That's the only way you'll start to really get the hang of it. All right, one more slide. And it says, what is the area of the inscribed rectangle if the diameter of the circle is 11 feet and the measure of arc BC is 60 degrees? Then we want to know what is the area of this rectangle. Okay, so step one is to draw in line BD. So get a ruler or a straight edge or a protractor or something to draw a straight line from B to D. That's going to be your first step. Draw that line in. We want to find the area of this rectangle. First thing we're going to need to do is draw this line because we know that the diameter is 11, okay, and the arc is 60 degrees. Next thing is that all rectangles must have right angles. So draw in some right angles here. We know that those are right angles. We know that we now have two right triangles. Step 3 is that BD must be a diameter. This must be a diameter since we have a right angle, a right triangle inscribed. Anytime you put a right angle here, this has to be a diameter. So that has to be a diameter. So I had to go through the center point. So put a point there in the center. Now since arc BC is 60, since arc BC is 60, the measure of angle BDC has to be 30 degrees. Because this is 60, half of it would be the inscribed angle over here. Because angle D is being intersected by arc BC, cut it in half, you get your angle. So this is going to be a 30-degree angle. Therefore, we have a 30, 60, 90 right triangle here. 30, 60, 90. Now, since we have a 30, 60, 90 right triangle with hypotenuse of 11, okay, we know the diameter is 11 because it says the diameter of the circle is 11 in the problem. So it has to be 11. The short leg then is going to be half of that diameter, 5.5. The long leg is going to be that short leg times radical 3, so it's going to be 5.5 radical 3. And you could use a calculator and figure out a decimal for that, but we'll just leave it as 5.5 radical 3 for now. So that would be that last part. And then the area, what we're going to do is take base times height. The base, 5.5 radical 3, times height, which is 5.5. So 5.5 times the 5.5 radical 3. In your calculator it goes, and you get 52.25 square feet would be the area of this rectangle. All right, there you go. Oh, don't forget the practice problems. You need to do the practice problems. They're on your paper, so get those done.